Alright, in this video I extracted some 2020 further maths questions to help our students writing 2021 further maths. And actually I would like to be of help if you have any problem that is bothering you in mathematics or in further maths. Just drop that question on the comment box. I will answer it, post the video so that I can help you out. I'm here for you. Just drop that question on the comment box. I will answer it and post the video for you. I wish you all the best of luck as you write your exam. Thank you. Okay, number one question is on binary operations. We have binary operation defined on the set of real numbers by P operation Q is defined as P plus Q minus P times Q over 2. And P and Q are all real numbers. So we are asked to find the inverse of minus 1 under the operation given, okay? And it is given that the identity element of this operation is 0. The second says we should prepare a true set of M operation 7 being equal to M operation 5. So let's see how you answer this question number 1. Okay, let's solve number 1a. We are asked to find the inverse of minus 1 under operation star, and it's given that the identity element is 0. Okay, so we have P star Q equals P plus Q minus PQ all over 2. This is what we have, okay? So let's solve for inverse of minus 1. So we say let the inverse of minus 1 be x. So I will now substitute and I'll have minus 1 star x. And because it's commutative, you can as well have x minus 1. And is equal to its identity. And here our identity element is 0. Okay, so a number star its inverse equals the identity element, okay, or its inverse operation, the number is equal to identity element. So here our identity element is 0. So we move forward to solve, applying the definition of this binary operation, which is minus 1 plus x minus 1 times x all over 2, and it's still equal to what? 0. Okay, we multiply through by 2 to simplify, and we will have 2 to minus 1 will give us minus 2. 2 to plus x will give us plus 2x, minus will give us plus. That's why I'm having plus now here. Then 2 here will cancel this 2. Okay, we'll cancel out this 2, and then we will have x remaining, and then it's all equal to the identity, which is 0. We add the like terms and we have this minus 2 plus 3x equals 0. And then we will now take 2 to the other side. The negative will now become positive, and then we'll divide through by 3. We'll divide through by 3, and that will now give us our final answer. This will now cancel this, and we'll have x to be 2 over 3. So the inverse of minus 1 is 2 over 3. We can check that out, which I did, and substituted for x, and we have 2 over 3 in place of x, and then we solved, and we have this minus 6 plus 6 over 6 giving us 0 over 6, which is 0. So try it yourself and drop your comments. If you have any question, just drop it on the comment box. Thank you very much. Okay, for number 1b, we want to find the true set of m star 7 that is equal to m star 5. Okay, So we have m still 7 equals m still 5. So let's define it according to the definition of the binary operation. Both sides we have, for the left hand side we have m plus 7 minus 7m over 2. That's it for the left hand side. The right hand side we have m plus 5 minus 5m over 2. Okay, then we simplify further, find the LCM, which is 2 on both sides, and then we will have 2m plus 14 minus 7m for the left hand side. On the right we have 2m plus 10 minus 5m. These two we cancel out those two, and we are left with 2m plus 14 minus 7m on the left, and then 2m plus 10 minus 5m on the right. Now if we work on the like terms, 2m minus 7m will give us 5m, and that is what I have here. Okay, will give us 14 minus 5m. Then on this side, 2m minus 5m will give us minus 3m. So we are having 10 minus 3m. We'll still collect like terms, and then we'll have 10 minus, okay, let's take 10 to this side, and if we take 10 to this side and then we'll take this 5 to this side, we'll now have 2m minus 4. Okay, then divide through by 2, this will cancel this, and then this will give us 2. Hence our m is what? 2. So we have m to be 2, and the truth set is a singleton set containing one element, and that element is 2. So try it out and drop your comments if you have any question. Thank you very much. Question number 2a is on composite functions. We have two functions p and q defined on the set of real numbers, and our p is 2y plus 3 and our q is y squared minus 2, and we have to find q of p. And the second part is on arrangement. Okay, so we are asked how many 4-digit odd numbers greater than 4,000 can be formed from 17382 if repetition is allowed. So we solve this now. Listen attentively, okay? Alright, we start with 2a for number 2, and we have two functions. So my function, I have function p and function q. So for p of y, this is it. P of y, that is my function p. Okay, is 2y plus 3. Okay, for my function q of y, that is my q, is y squared minus 2, and we are asked to find q of p. Okay, q of p of y. Okay, so that is what we are looking for. So my q of p will now be this. Okay, let me explain here before I go further. Remember, my q of y is y squared minus 2. So my q of p now will now be p squared, okay, minus 2. Remember, my q of p now will now be p squared minus 2. But p is given as what? 2y plus 3. So that's why I'm now having, in place of p, I'm now having 2y plus 3 here, okay? And then it is squared. So I'm having 2y plus 3 all squared. Then minus 2. Now to expand this, I'm having 2y plus 3 multiplying itself, 2y plus 3 minus 2. So if we expand, we have 4y squared plus 6y plus 6y plus 9 minus 2. Okay, this is the only square we have here, so we have it back here. 6y plus 6y gives us plus 12y. 9 minus 2 gives us 7. So this is our final answer. And here I have my q of p. So that is how you do it. So try it again and again. Drop any question on the comment box and I will attend to it. Thank you very much. All right, we are on to number 2b. How many 4-digit odd numbers greater than 400 can be formed from 17382? Okay, with repetition allowed. So we need to fill in 4 spaces. Let me get my pen. Okay, so we need to fill in 4 spaces for us to have the 4-digit odd numbers greater than 4,000. Okay, so we need the 1,000th digit, we need the 100th digit, and we need the 10th digit, and we need the unit digits. Now let's start with the 1,000. Okay, if we have 1 to form the 1,000, okay, it will be less than 4,000. If we have 7, yes, it will be greater than. If we have 3, it will be less than. If we have 8, it will be greater than. If we have 2, it will be less than. As we have 2 digits, 7 and 8, that can fit in for the digits we need for our 1,000 to be greater than 4,000. Okay, so we have 7 and 8 only. Now for the hundreds, the 5 digits can go, no problem. For the tens, the 5 digits can also go. So that's why I said, meanwhile, all the 5 digits can take the position of hundreds and 10. But when it comes to the units, we need only odd numbers, okay, because we want odd numbers greater than 4,000. Okay, so we need only odd numbers in the unit digits. Okay, and the odd numbers we have 1, 3 and 7, 3 of them, just 3 odd numbers. And that is why I'm having 4,000 2 times 400 5 times 4 tens 5 times 4 units, which is 3. So if you multiply them, you have 150 ways to form these odd numbers that are greater than 4,000. So we have 150 ways that can be formed. Okay, that is how to answer this question. Thank you. All right, we have our question number 3, and we have a definite integral to evaluate with respect to x, and we have the function 3x minus 2 raised to the power 5. So let's integrate and then evaluate. Okay, all right, this is the solution for that definite integral. So we'll start by integrating first. So I will integrate. So this is how I did my integration. I let this 3x minus 2 to be u. So I take the derivative of u with respect to x, and I have the u over the x to be equal to 3. And then I made the s the subject because I want to replace this. So I will have the u over 3. Okay, so this is it now. the x is now the u over 3. Now I will substitute u for 3x minus 2, and this is what I have here. And then substitute the u, okay, the u here over 3 for the x, and that is why I'm having this. Okay, so I will now integrate u raised to power 5. Okay, and if I do that, remember you're adding plus 1 to this power. Okay, you add plus 1 here and divide by 5 plus 1. Okay, so that's what I did that resulted to this. Okay, so we now have u raised to power 6 over 6. Okay, I'll multiply 3 by 6. Okay, and that gives us 18 here. Then I will replace my u with this 3x minus 2 because that's what it represents, and raise it to power 6, which it is what we have here. So I'll have that, and remember it's a definite integral, so we'll now have we've done our integration, so we'll now evaluate. Okay, we're taking our evaluation from 1, okay, 1 and 3. So we'll substitute the first value, which is the highest value here, the 3, into this x, sorry. So I will now have 3, which is this 3 here. Let me get my pointer. So I'll have this 3 here. Then for this x, I will put 3, this 3 here, minus 2, all raised to power 6 over 18, minus the second now will be for 1. So I'll have 3 times 1 minus 2 raised to power 6, which is what I have here, all divided by 18. So this will now be 3 times 3, which is 9 minus 2, all raised to power 6 over 18, minus this times 3 is 3 minus 2, all raised to power 6 over 18. So if I subtract, I have 7 to power 6 over 18. If I subtract, I have 1 raised to power 6 over 18. So I will now find 7 raised to power 6, and you have 117,649. And 1 raised to power 6 is 1 all over 18. And if you divide, you have 6,536. So try it out and you will get the same answer. Okay, we are making progress. We are on number 4, and the question is on partial fraction. So we have a first fraction here. We have if 3x raised to power 2 plus 3x minus 2 over first bracket x minus 1, second bracket x plus 1 is equivalent to p plus q over x minus 1 plus r over x plus 1, that we should find the value of q and r. So let's see what the value of p, q and r are. Okay, all right, this is how I solved my question number 4. I first of all find the value of p, though it's not in the question, but I wanted to do that, and it's very needful to do that. Okay, so since there is a variable there, you need to find that variable. It's very important you find your p, and since it's p before q, okay, this is p before q, you need to find it before q and r. So it's very needful. So it's a bonus if you do that. Actually, it's a bonus if you do that, though it's not the part of the question, but it's a bonus if you do that. So first thing I did is to find my p. And what did I do? I multiplied the numerators so that I will have this expression x squared minus 1, and that's the difference of 2 squares. Okay, then I divided 3x squared plus 3x minus 2 by x squared minus 1, and this is where I did it. So let me explain to you how I did the division. Okay, So this is what I did. I divided 3x squared by x, okay, by x squared. So this is it, 3x squared, okay, by x squared. Okay, this will now cancel this, leaving us with 3, and that is why I have my 3 here. Now secondly, if I want to divide further, you will notice that this cannot divide this. The power here is 1, this power is squared, 2, so it cannot divide. So I had to stop. Okay, I had to stop because the power cannot be divided. This is higher power and this is 1, this is 2. So what I did is to multiply this x squared minus 1 by 3. Okay, so I can get the remainder. Okay, so I multiplied x squared minus 1 by 3 to get this remainder. So this is how to do it. So first I will multiply 3 by x squared, okay, and that gives us, sorry, this should be cosine, let me clean it off. Okay, so if I multiply, I will have 3x squared, 3x squared, okay, and that's why I'm having this 3x squared here. Okay, next I will multiply 3 by minus 1, by minus 1, and that gives me minus 3. Okay, that gives me minus 3, and that's why I'm having this minus 3. Okay, so I'll now subtract. Okay, I'll subtract and I'll have this one would be minus 2 minus minus 3. Okay, minus 2 minus minus 3, minus minus will give me plus, and that will be minus 2 plus 3. Okay, this is plus 3, and that is equal to plus 1. Okay, plus 1. So that's why I'm having this plus 1 here. Now for 3x, it has no like term, so we'll just bring it down. Okay, let's bring it down, and then I have 3x squared minus 3x squared, which is 0, so I don't need to put 0 here. So, and like I said before, the power here is 1, the power of variable here is 1, the power variable here is 2, so it can be divided. Okay, so this is the remainder. Okay, so we'll now have to reduce this expression here, now this our expression here, now bring it down in this form. This 3 here now becomes, okay, we have it here, plus our remainder, which is 3x plus 1 over the divisor, which is x squared minus 1. Okay, and then I have it back in the right way it's given. Okay, now you can see now is on the same plane with what we have on the right side of the equation. So that to say that P is equivalent to 3. Okay, and that is how I concluded that P is equal to 3. So now we know our P, we can now find our Q and R. So let's go. All right, next is to find Q and R. Q and R. So we are done with P. Let's find the Q and R. So this is what I did here. It's already solved, but let me explain what I have here. Okay, I have the remainder 3x plus 1 over the product of the two linears, x minus 1 in the first bracket and then x plus 1 in the second bracket. So is equivalent to q over s minus 1 plus r over s plus 1. Okay, So what I did is to change these two fractions to single fraction. I turned them, I converted them, I made them single fractions. Okay, so here is the single fraction. I'm multiplying finding the LCM, it's just multiplying them. So I did x minus 1 in the first bracket multiplied by x plus 1 in the second bracket. That's the product of these two. Then divided this multiple by x minus 1. I have x plus 1 remaining, so multiplied it by q, and this is the result. X bracket x plus 1, close the bracket. So I'm done. Plus this plus here, that's what we have. So divide this. Okay, divide this product by x plus 1. I have x minus 1 remaining, so multiply by r. We have r bracket open x minus 1, and this tells us that this q bracket open x plus 1 close plus r bracket open x minus 1 close the bracket is equivalent to this remainder 3x plus 1. So that is what I have here, that 3x plus 1 is equivalent to qx plus 1 in the bracket plus r x minus 1 in the bracket. Now let's start by finding q. I'm going alphabetically, so I have to find q. I look for how to eliminate r. Okay, so what I did is to use the inverse, the additive inverse of minus 1, which is 1. Okay, so if I put 1 here, this bracket becomes 0, and if we multiply r by 0, it is 0. So that is what I did. So since my x now is 1, every x will now be substituted by 1. So I have the first one, 3x will now be 3 times 1 plus 1, equivalent to q 1 plus 1, that is x plus 1 will now be 1 plus 1 plus r. For x now I have 1 minus 1. So 1 minus 1 here becomes 0. So multiply r by 0, you have 0. So 1 plus 1 here becomes 2. Multiply q by 2, you have 2q. Okay. Then here I have 3 times 1 plus 1, which is 4. Divide this by 2, both sides by 2, and you have your q to be what? 2. So now we know our q. Our q is 2. Next, to find r. To find r, we look at how to eliminate q. Okay, in this expression, to eliminate q, we go with the additive inverse of plus 1, which is minus 1. So in place of x now, I will substitute minus 1. So I'll start with 3x plus 1. So that will be 3 times minus 1 in the bracket plus 1, equivalent to q. For x, I will now have minus 1 plus 1, okay, plus r. This r, then I have minus 1 minus 1. So for this minus 1 minus 1, it will give birth to minus 2. Multiply r by minus 2, you have minus 2r. For minus 1 plus 1, here is 0. Multiply it, you have q to be 0. So here q is eliminated. So here I have minus 3 plus 1, which gives us minus 2. Divide both sides by minus 2, you have your r to be 1. So our r is 1. So finally we have our p equals 3, our q equals 2, and our r equals 1. So try it on your own. Get a pen and paper and then try it again and again, and you will see you will get the same answer. If you have any question, drop it on the comment box. I will attend to it. Thank you. Question number 5. Okay, we have a table, mark, and frequency. Class interval 1, 10 to 19, 20 to 29, 30 to 39, 40 to 49, and up to 90 to 91. We have the frequencies on each of the class intervals. This is a frequency 2 for this, 2 for this, 2 for this, 2, 8, 13, 11, 12, 10, 4. So Let's see the question behind this. Okay, so the table shows the distribution of marks scored by 64 students, okay? And we are asked to draw a histogram for this distribution. And then use the histogram to estimate the mode. Okay, let's do this together. Okay, before we draw the histogram, we need to find the class boundaries, which already I've done. Let me explain what I did here. For the first interval, okay, the boundary we have here, we have 9.5 and 19.5. How did I do this? So what I did, you subtract 0.5 from the lower limit, lower class limit, and then add 0.5, the same 0.5 to the upper class limit. Okay, so for this also you subtract 0.5 from this. You keep subtracting from the lower class limit and adding to the upper class limit the same 0.5. Okay, so work it out as I'm doing this. Minus 0.5, okay, plus 0.5. So do it till you get to the last class interval. So I'm jumping to the last class interval, which is 90. Subtract 0.5 from 90, which is the lower limit. Then add the same 0.5 to the upper class limit, and that gives us 89.5 as the lower class boundary, and then 99.5 as the upper class boundary for the interval. The frequency remains the same. So you still have your 2, 8, 13, 11. Nothing changes here, but these boundaries are needed. We need these boundaries to work at our histogram. To draw our histogram, we need the boundaries because the bars are connected. So we need to connect the bars and connect them rightly. You can see the connection now. I'm just showing you how they are connected using the boundaries. Okay, so let's go. Okay, here I have my histogram. You can see the bounds here, the boundaries. Okay, so this is 9.5 to 19.5, 19.5 to 29.5, and so on and so forth. But this is not the best way to put the bounds. The best way to put the bounds is on the boundaries, okay? And because we are not starting from 0, there should be a space between 0 and the rectangular bars, okay? So here I'm supposed to have 9.5, okay? For my first bound, 9.5. Okay, so this shouldn't be here. Then next I will have 19.5 for this second bound, that is this one. Now then for the third I will have here, okay, 29.5. So do it for all of them, put it well. This will now be 39.5. Okay, so that is it. You keep on putting, the bounds should be on the boundaries. Okay, all right, so to find the mode, we locate the highest bar, which is this, the bar with the highest frequency. Then join the vertex to the next bar, okay, and this one to the next bar. Move it, use your meter rule. The point of their intersection, use dotted line or broken lines, better broken lines, and move it using your ruler. Okay, move it until it touches your marks. Okay, that is the x-axis. Keep moving it. So where it touches it is where your mode lies. So for me, my mode is 56.5. okay, 56.5, and that is our final answer. So here is my histogram, and the mode, here is my histogram, and the mode from this histogram is 56.5. So try it using your graph paper and you'll get the same answer. Thank you. Here we have a number 6 question. Number 6 is on probability a bag contains 10 red and 8 green identical balls. Okay, and 2 balls are drawn at random from that bag, one after the other without replacement. We have to find the probability that one is red and the other is green. Secondly, we have 20% defective bulbs in a large box, okay, and 12 bulbs are selected. 12 bulbs are selected randomly from the box, okay, and we have to calculate the probability that between 2 and 5 are defective bulbs. So let's see how to do these. Okay. All right, to solve 6a, you must know the total number of balls you have in the bag. Okay, for us now we have 10 red and 8 green, so we add both and that will give us 18 balls. So we have total of 18 balls in that bag, okay, in the bag. So we have 18 balls. Now we are looking for probability of one being red and the other being green. The two balls, okay, one is red and one is green. So it's possible that the first is red and the other is green, or the first is green and the other is red. Remember, it is without replacement. So if the first is red, we'll have the 10 number of red balls out of the 18, which is the total number of balls, times the second green. Now we have 8 green over 17. Why is it 17? Because we have taken one of the red balls out, and it will now cause this to now be a total of 17 balls. Or that is plus now, or is plus. Okay, or we'll have the first to be green, which is 8, out of the total number of balls, which is 18. And because we are not replacing it, it will be multiplied by 10, which is for red, out of 17, which is now the remaining number of balls. If we multiply 10 by 8, we have 80. 18 by 17, we have 306. The same on the side, if we multiply 8 by 10, we also have 80. And then 18 by 17, we have 306. So we are having 280 over 306, and that is what we have here. Okay, so we cancel out and divide, and we have our answer to be 80 over 153. So the probability that one ball is red and the other is green is 80 over 153. So try it and drop your comments if you have any question for me. Thank you. All right, for 6B, we have 20% defective bulbs. Okay, so let me get my pointer. Here we have defective bulbs, and 20% we change to decimal, and it's 0.2. So let that be my P. Okay, this is my P. Okay, and then for defective bulbs we have now, minus 20 from 100%, we have 80% remaining, which is 0.8, and that is my Q. Okay, and we are saying that the probability of X, okay, is equal to N over X. Okay, P raised to power X, and then Q raised to power N minus X. Okay, so that's what we are going to use. And then we are asked to find probability of selecting between 2 and 5, okay, defective bulbs. Okay, so because it is between 2 and 5, we go for integers between 2 and 5, and they are 3 and 4. Remember, we are not told that 2 and 5 are inclusive, and because of that, we are not going to consider 2 and 5. We'll just go for integers between them, which are 3 and 4. So we look for probability of X being equal to 3, and this is it now. So our N is 12, and here is X is 3, and we have it 3. Then our P is 0.2 raised to power X, which is the number of defective bulbs here, 3. And then the non-defective, we have 0.8. And if we subtract 3 from 12, we have 9 remaining, plus here we have 12 and 4, and then because this is for 4 now, and 0.2 is raised to power 4, and then 0.8, if we subtract 4 from 12, we have 8. So you do your normal arithmetic, take the combination, and you have 0.2362 for this now, plus you do this, you have 0.1329, okay? Then add the two numbers, you have 0.3691. So the probability of selecting between 2 and 5 defective bulbs we have is 0.3691. So if you have a question, any question on this, drop your question on the comment box and I will attend to it. Or you have any question related to it, just drop it, I will attend to it. Thank you. Our number 7, we have forces. We have F1, we have F2, we have F3 acting on a particle. Okay, F1 is 10 Newton, 90 degrees, F2 20 Newton, 210 degrees, and F3 4 Newton, 330 degrees acting on a particle, and we have to find the magnitude of the resultant force, and our answer should be in 1 decimal place. Okay, so solving this, the first thing to do is to resolve the forces so that we will get the vertical component and the horizontal component. So here we have our 90 degrees and we have our F1 10 Newton, and then for 210 from here to here is 180. So if we add 30 from this quadrant, we have our 210, and that is our F2. So for 330 degrees from here to here is from here to here is 270. So we need to add 60 to it, okay, so that we get 330. So we added, and on this quadrant we have our 330 for F3. So going further to resolving, so that we'll have our horizontal component and vertical component. This is what we will now do. Okay, so for F1 now I will have 10 sine 90 for the horizontal component, and then 10 cos 90 for the vertical component. So that will give us 10 0. Okay, x is 10, y is 0. Now for F2 I'll have 20 sine 210 for horizontal component, and then for vertical component I have 20 cos 210, and that is minus 10 for x, and then minus 17.32 for y. For F3 I have 4 sine 330 for horizontal component and 4 cos 330 for vertical component, and I have minus 2 for x and 3.46 for y. Now for my resultant force, I had to add the 3 forces. Okay, so I'll add F1, okay, plus F2, okay, plus F3, okay. I'll add the horizontals, that is 10 plus minus 10 plus minus 2, and that will give me minus 2. Add the vertical, 0 plus minus 14.32 plus 3.46, and that gives me minus 13.86. Then I'll find the magnitude of the resultant forces by taking, okay, the sum of the squares of the resultant force and then take the square root. Okay, so the sum of the squares will now give me 196.0996. the square root will give me 14.003556669. to one decimal place I have 14.0 Newton, and that is the final result. My number 8, and I have vectors. Okay, I have 3 vectors here. Let me explain. Vector W, I have 8i plus 3j, x I have 6i minus 5j, y I have 2i plus 3j, and I'm told that the magnitude of z is 41. Okay, what are we looking for? They say we should find z in the direction of w plus x minus 2y. So we are looking for z in the direction of w plus x minus 2y. So this is how you do it. Okay, so let's now work out our w plus x minus 2y. So this is my w, 8i 3j, plus my x is 6i minus 5j. I'm going to multiply y by scalar 2, that is minus 2. So I'm going to have minus 2 multiplying y, which is 2i plus 3j. Okay, so if I do the arithmetic, 8 plus 6 minus 2 times 2, that will give me 10. 3 plus minus 5 minus 2 times 3 will give me minus 8, and that is what we have here, 10i minus 8j. So with that, now let's find z in the direction of w plus x minus 2y. So that will be the magnitude of z times the unit vector of w plus x minus 2y. So this is the unit vector, that is w plus x minus 2y over the magnitude of w plus x minus 2y. That is the unit vector of w plus x minus 2y. So we are given that the magnitude of z is 41, so we have it there, 41. Then our w plus x minus 2y is now 10i minus 8i. So this is it. So I will now find the magnitude of w plus x minus 2y, that is taking the sum of the squares and then take the root of square root of it. So this is 100 plus 64. Okay, 100 plus 64 will give us 164, and if we simplify further, it will be 2 roots 2 root 41. 2 root 41. Okay, so we rationalize. If you take the rationalization of this, you now have root 41 bracket open 5i minus 4j. So this is z in the direction of w plus x minus 2y. Okay, to do that, it is the magnitude of z times the unit vector of w plus x minus 2y. At the end, this is our result. The square root of 41 bracket open 5i minus 4j. The vector, close the bracket, and you have your answer. So you can try it or try another question related to it and drop your comments on our comment box. Thank you.